Yeah, I'm going to talk today about particular tool which we use, which we developed and use for database change management. And I don't know, I probably put my bar a little bit low. I don't know how well people know what change management is, and first I try to explain how things done on another side, on the software development. That's where the idea actually came from. And here outline, and I'm going to talk about revision control system basic, because usually most of the database change management software in some way resembles these main ideas. And after that I will talk about database change management directly, how it is done through that tool, and we'll describe what tool does and the tool itself, some usage and influence of this tool and methodology on management of the script which essentially input data into the database. That kind of outline, and with this I would like to talk about revision control basic. But first I would like to say that usage of databases significantly changed the practice of software development. Before, and I was a software developer for more than 20 years, we never worked with databases, and actually database programming was completely different from programming. And now with internet, they became much closer, and for some type of applications you have to know both, and you have to work with both. And it again significantly changed how people used to write code and to work with code, to manage the code. And that's what essentially my talk quite a bit about. For people who aren't familiar with revision control as software engineering, I will explain it. Usually when developers write a code, they have to make sure that the state of their code is recorded somewhere. So if they change their file or two, you always can come back. You can track when the changes have been done, by whom, and what the changes are. And here you see that's how software developers actually track changes in their source code. And that is called revision control system, or RCS. One of the basic operations over there is so-called check-in. And you see how it works. Probably it will be easier.
You have to point at your computer. I do that all the time, pointing at the screen.
Oh yeah. Yeah.
Oh, it's just the laser.
Yeah. So this is empty file, and the developer puts some line, milk for example, over there, and check that file in. So now the developer got the revision number. So the second time when he or she adds another line and check it in, it got another revision number, and so on and so on. That's a basic operation. But in addition to checking in, what developers do, they check things out, and you see now what you have, and you can edit your file, and the changes will be recorded. You got a different version number, but also you can roll back, or whatever you call it, retrieve, and get your previous version. You can revert to the changes which you have done. And when you check out, you got the latest version by default. And if you want, you can even specify particular revision. What's important here is the idea of diffs or deltas. Means the change, particular change which you apply and got the next version. And here the people usually call it like a trunk, and the trunk has history of changes as file evolves. You see here that all of that stuff is a delta, that type of things. So, for example, to get from R1 to R2, I added eggs plus eggs, and to get from R2 to R3, I added juice plus juice. And to get from R3 to R4, I removed juice and added soup. So juice is minus and soup is plus. What's interesting is that most of revision control systems store diffs, not the full file copy every time, obviously. So it saves disk space. Instead of 4 revisions, you have 1 copy and 4 small diffs. That's what I provided here, and this is a very basic knowledge, but it is sufficient for our purpose, and it will be quite useful when I will describe how our stuff works. Again, I already said that usage of databases significantly changed the practice of software development. So when developers work with the source code, which heavily use databases, again, this is majority of applications, internet applications, which is a now major stream of software development, really. They usually try to apply revision control logic to the data of database. And here they got problems. They think in terms of deltas. But when you're talking about database, this nice idea of deltas really doesn't work very well. First, comparing with the source code, the data in the database, huge. Yes, there are differences in data, but when we were talking about gigabytes, comparing with the source code, when you can look and understand what it is, here you have like at least few megabytes of differences. There is no way to do that, to understand what it is. Second, and this is the most radical change, the code and the data are separated. Data in database, code runs on computer and stored in some repository. The data not stored in the repository, they're in the database. And what is interesting, the correct code will not work with incorrect data. So the question is, there is no explicit link between source code in the source code repository, like Subversion, for example, and the data in the database. But it should be, because if they don't match, it doesn't work. And it's enough to have a very small mismatch, and the application will not work. So what to do? In order to create such a link, we have to create precise and compact description of the data in the database, assign it to particular revision control version of the source code in the repository. This way we can ensure the connection between correct code and correct data.
Now, when you say data, do you mean like the actual data, or do you mean the schema, or both?
Essentially, I assume the schema is kind of known. No, I mean, I will talk about that a little bit later. Yeah, you will see. I will explain what
you're talking about the data in a fixed table at the moment.
I will talk about that little bit. I have a special slide about it. So what we're supposed to use in order to describe precisely and compactly that data? In our case, we decided to use SQL scripts, which contains those data and essentially insert them into database. When you start to work application, the database is empty. Yes, Sherry, I assume that schema is already there, but of course it is not necessarily, because you can create a wrong schema as well, but you can include those scripts which produce schema in that definition as well, and I will also talk about that. And this way you ensure that you got correct schema as well. And there is a one-to-one mapping between those scripts and the data. I mean, including schema, including DML, which they produce. So once you link your repository for source code to those files, you hope that you created precise and exact mapping between source code and the database, not mapping, but link. Source code in the repository and your data in the database. But those scripts also could be under revision control the same way as the source code. And here, coming to the question of data, I would like to say a few words about data in the database. Kind of would usually talk about it kind of fluently, but when I'm talking about data, first I mean enterprise application. You know, Amazon could be eBay, something like, or big corporation which has a lot of data coming in, the data coming into operational store, change the state of that store, and influence the work of other applications which read that data, you know, and perform useful work. So transactional data. Transactional data really reflects small, minute changes of the application state and accumulated in the database as a result of application work. Also, they inserted in the database after application already started to work. Again, talking about Amazon, for example. I don't know, in the first day of world creation, Amazon didn't have anything running yet. The database was already there. And they started up their application, and people started to do transactions, and data started to accumulate in the database. Those data change with time, so they're important for the application work history. But there are other data which are even more important. They are non-transactional. What it means, they already were in the database. Without them, Amazon cannot work at all. They have to know currency. They have to know, so many things. And when I worked at another company, we worked with real-time sensors, like radars, for example. Now you have to keep coordinate systems in order to make your sensors understand each other. And those data should be in before you start up your application. This is crucial, and if you can make a mistake in transactional data, some wrong value of book or something, but you cannot make mistake in those data. Application just will not start and it will be complete chaos.
Are you talking about DDL as well as DML?
Definitely transactional data are not DDL. Transactional data...
I'm talking about what you're saying, non-transactional data.
Non-transactional data, definitely they don't change with transactions. Your table formats stay over there. But in addition to the schema, there are DML data.
I'm asking what you're talking about tonight, your system, does it handle keeping track of DDL as well as non-transactional DML?
Everything.
Okay.
Everything. And I will talk about that and show how to use not only DML and DDL, but DCL as well, if somebody remembers what it is.
I do.
Yeah.
Would the term metadata be appropriate to describe that?
You can, but from my purpose, I wouldn't separate important data from metadata.
Okay.
By metadata, you mean like schema, for example.
Well,
but
data,
there are
but data about data.
Right,
yeah,
right.
it's a technically, it's a correct term, but most people, when you talk to a database person about metadata, they're going to think about the metadata that's in the database that the database calculates, not like what countries is this application valid in.
Right. Okay.
So it is
Well,
metadata for the application, but
Right,
that can be a
application
confusing
metadata.
term.
Yeah.
I think of it more
It
as...
is good. Usually for such a data, there is a name. People who do data warehousing, they use, again, I'm not talking about DDL, I'm talking about DML. For that type of data, they use word reference data. Yeah. Again, the coordinate system, currency, geographical data, things which you load one time and usually don't change very much. But the developers definitely work very heavily with those data, and it could be conflicts. They change their definitions, and that's what we're trying to track.
Okay.
Yeah.
Yes, and here are the example, like coordinate reference frames, inserted in the database before applications start to work, cannot be deleted, and you don't change very much with time. So,
Right. So actually, what I usually do is I bring this kind of thing up in the course of talking about disaster recovery. Because, what does disaster recovery mean? Does it mean being, if you're Amazon.com, maybe you can't get your order history, but like what's easier to do? Let's say you have a, big corrupt something or other. It's certainly probably a lot easier to get another copy of Amazon.com running, whatever the website in the database is, so that people can do new orders than it would be for them to, get all that background data and stuff. And I think everyone has that. So that's, reference data.
Again, they don't change with time, and application relies on that. So they should be protected, and their changes, because there are changes, should be tracked very carefully. And revision control mostly needed for non-transactional data. Transactional data are kind of less significant, but they're also significant because it's money. Yeah. So now, I'm going to explain the database change management and reasons for database change. Requirement changed, and now we have to change those reference data. Now instead of Earth 84 model, we started to use Earth 92, and instead of that type of ellipse, we now use different one. A team of developers working on one central database and started to merge something. Team of developers using multiple local database want to synchronize. And the basic questions when you do change management in terms of tracking, I would say you have two databases. Are they the same or they're different? And that is a basic fundamental question. And just looking at data, you cannot answer that question. Because data could be in different order. In the table, nobody put data in the same order. But we know that that table is exactly the same as another one. And it's difficult to look at gigabyte of data. And this is a problem, which human beings are quite weak on. Yeah. Second fundamental question, okay, they're different. Is it a lot of differences or just not too much? And how much we have to do in order to make them exactly the same? Especially this is important if you have a production, if you have a staging, and if you have a development environment. Now you really care, are they the same or are they different? And unfortunately, what different means different. Yeah, for production, transactions more important. For developers, they really don't care very much. So that's important thing to consider. And when changes happened, somebody changed those files. Who did it, when it was, and what a particular change was. If error happened and you back out the corrupt version, up to which point you getting back? And you have to, it should be well known and point where we know that there were no problem. Yeah, that type of things. So based on this kind of questions and problems, we essentially developed database change management procedure, created log, created database delta scripts using naming convention for the script, and apply the script and change the script into revision control system like subversion. And here, that's important picture. Important picture because here you see the tool which we developed, the catalog version tool. Here you see the repository, revision control repository, like again, subversion, whatever you use, where those scripts are. And the tool takes scripts from there and applies them to the database, creating the schema, putting those data, and simultaneously recording that process, which scripts has been applied in additional table in the database, which keep track of all scripts which have been applied. And now the collection of all scripts which have been applied essentially represent the database. So instead of multi-gigabytes of data, you have, maybe 50, maybe 200 lines, and essentially with those 200 lines, you precisely describe tens of gigabytes of data. And that was really interesting. Because now you have concise description, you don't care what order of data in the database. And to compare those lines over there, I will talk more, of course, more about that. Compared to few hundred lines, it's not a big deal. It's familiar text processing operation, which we, software developers, know very well how to deal with. Whole programming is processing of handling of text. Now we can do that, and we can compare. We can find the difference. We can find the similarity, and that is enough for description of the data inside the whole database. Yeah. So you see, this is a concise, quick, and compact, and revision-controlled representation of the database state. You can say, yeah, here, that's good view. That was the table. It's not necessary. We use that format, but important thing that you have to record the name of the script which produced some data. You have to have the revision ID, which corresponds to the revision ID of the source code, which asked for the data to be installed. This is a revision ID minor. We use Subversion, so it's exactly the number. When you check in your file, Subversion gives you the number. You remember at the beginning I talked about R1, R2, R3, that exact number. Here insert time, of course, and here some comments, usually it's nice to have them.
How do you know the SQL file name is what you think it is?
That's what it is.
How do you know it hasn't changed? What
The
version?
DBA didn't change it.
Because it is under Subversion, so under the repository. So when you apply it, you take it directly from the repository under revision control and apply.
So you're assuming that, and you're assuming no by hand changes.
If somebody changed that file, we can track in revision control.
No, I'm sorry. So there's that assumption that everything there is under SVN, and there's also you're assuming that no DBA is going in and making some changes without.
And run it, yes, and that's very true. That's an important thing. That only access to the database allowed from kind of automated control thing. In reality, it is not 100% so, because there are situations when you have to do something, but as a rule, that's what it is. There is no human being over there.
And does your if I'm reapplying this, if I want to
Oh, it's good question, and if you unfortunately it's slow, you probably don't see that. The catalog version tool does not override existing files. So once it applies, let me come back here. Once it applies those files, you understand that this table is exactly this one. Do you? Yeah, that's an important thing. So once the tool sees that the name here, and the name is exactly the one which it is going to apply, no, not going to override. What it means that you can apply your changes incrementally. Usually people say, build database on the top of another. And that's very nice, because there are two ways of doing this operation. Sometimes you need to create the database from scratch. Just apply all those scripts and you have a clean and did it. But in many situations, the developer released some piece of code, also developer released some SQL script, and they want to apply to already existing thing.
Is your tool tied in with SVN so it checks out?
Yes, Yes, it is tied in through Perl essentially. Perl calls that tool, and Perl knows the revision number, and that tool takes that revision number, puts it in, and that's the way it is recorded. It is even more than that, because yes, each SQL script is a delta. You remember that delta like a milk, like particular line. For our huge database, each script, I mean data which were generated or produced by that script are delta. And when we're talking about delta, it could be, that's why I didn't make that distinction. It could be different schema. It could be, outer table, add indexes or something like that. Or it could be, particular numbers in another country, another coordinate system, whatever you want. But important thing is that now you can kind of keep your delta in your hands. And it's nice, because you see what it is. And here, important thing, we will talk about that. There are situations, and they're not uncommon, that the source code changes more frequently than the database content. Obviously, schema doesn't change very much, really. But source code is always changing. People put comments, then commented something, put additional space, whatever. There is no end of that. So, and we would like to make sure that even after that insignificant change, we still can map the state of the whole database to the state of the software. But what happened here, that catalog version ran those scripts, and all of them already have been applied. So, what to do? The software changed, but the database didn't. You understand? Because some guy changed comments or whatever, which has nothing to do with the database. But we still have to provide that link. What it means is that now we have a second table. And you as a database people understand it very well. So what it means is that this is the last, let's suppose this is the last real change which happened. We applied that file and some data have been input, whatever the data is. And on the next thing, we have a foreign key here which refer to that particular record every time when you run your software. Yeah, that's happened. No, nothing has been inserted. What it means is that every run after nothing has been inserted relates to that last record which we insert. And here it is recorded. So even if nothing has been inserted, we still have a track of those changes. But it will be one to many maybe, because it could be multiple runs of the software which didn't produce any changes in the database. That essentially a kind of idea, and I will speak more on how to manage those scripts, because now you see your scripts are your major treasure. You don't throw them after you apply them, but you keep them because they provide you the history, the deltas, and all of that stuff.
Is this just for MySQL databases, or could it be used for any database?
Oh, yeah, for any database, yes. It is, and I will talk about that because of the tool written in Java. Only JDBC. And all Java up 1.4, maybe even before but 1.4 is old enough. So yeah, that's enough. And here, important thing, we have currently for our application, we have few hundred those files. Few hundred, it's a sizable number to make a mistake. So we started to classify, and here how we classify that, and it's important that schema, because usually how many schemas you are going to have in the database. Not tens, probably, unlikely 1,000. Yeah. Also, execution number, which is very convenient, and I will explain why. Content category, and by content I mean DML, DDL, DCL, and once you know that category, now you know in quite well what the order of application should be. You know that DCL very likely goes before DDL, and DDL very likely goes before DML. And the last category, we don't use it really very much, is a DTL. We call it transactional data, data transactional language. Just describing, sometimes we might want to inject transactions for testing for some kind of purpose, that type of things. And explanation, and of course, timestamp. Sorry. Now we no longer use timestamp. Timestamp is we put it in the table. Yes. But if you want to, you can do that. What important things to have a relatively uniform format. So when you look at that table, by the table I mean there. When you look at the table, you can read the file names and understand their structure and have some idea at least what they are about. You don't need to know exactly, especially when you're just browsing and everything is okay. Did you why application doesn't start? Oh, you look through that. Look, they forgot to insert file 33 something, and you can understand it very quickly and easily. So now I would like to talk a little bit more about the program itself. That's what your question is about. It's a Java program, JDK 1.4 and better, and applies SQL scripts to MySQL server. We use MySQL, but I'm very sure that it could work for Oracle if the statements inside SQL scripts are Oracle compatible. Because what that stuff does, it essentially parses the SQL statements inside SQL scripts and apply them as a Java does, as a SQL commands to the database. And here you have kind of jar files. It's very, very common. If you want to run it against Oracle or SQL Server, it's exactly the same. And there are multiple options of that program, and I will talk about the code design as well. So you see, you provide username, you have password, server IP, that typical thing. You have important thing here, SQL file list. What it means that you have a directory in your repository, the revision control repository, and that directory contains the list of files, usually kind of list of files in that directory, but not necessarily. You can take that list and just read your SQL scripts from that directory and apply them. Essentially like a catalog of the content of the directory. That's what you use. It is convenient because sometimes you don't want to apply everything content to that directory. Revision control is a little bit inflexible. You don't want to delete and add on just everyday files. So it's easy sometimes to delete things from script than physically from the directory. That's the reason. Also, you have a port number, so you can do that. You can apply one particular script. You can apply even scripts which produce errors. And that's an important thing. So you apply something and you found that there is an error. And the tool stops. Here kind of major drawback, which could be done, but I didn't write it yet, transactionality. But it will be nice that once you got an error, it rolls back everything which is been done, which is not difficult to do. But we didn't implement it yet. Nevertheless, so there is an error, but sometimes you want to go proceed regardless of the error. Because you know what it is and you don't care about that error. So you can do that. And also there is a comments which you can put in, which is convenient. And here, for example, that is just a file, script. You can use if you use a shell bash, for example, you can pretend that this is a bash shell. If you use Windows, you can run that stuff from either Windows or from Linux. And I do that with equal success on both. Well, the only thing what I have to change, instead of .bat, I have to replace with a .sh and do some, you know, Windows versus Linux line ending, that type of thing. Other than that, Java is exactly the same. So that's what we run, and each sequence file here contains something like that. Those files, and here are individual SQL scripts, which in turn contain SQL statements. A lot of them, could be 1,000, could be 2,000, whatever you want, and this is your delta. So once it runs, you will see the name of that file in that table. And you know it has been applied, you know what it is, and those guys are under revision control.
So, catalog version is a normal table, right?
Yes.
So
Actually, two tables. You
right,
know,
right,
yeah,
revision.
yeah.
So there's a window of those scripts are DDL as well as DML.
DCL, DDL, and DML.
So after the script is run, there's a window before you can apply it. It's a small window probably. The fact that it has run and recorded to your table.
You mean, yes, it is the name only inserted if the script runs successfully. If not, then we will not see that. Yeah. And here a little bit about the design of that tool. It's the 3,300 lines of Java code and 5 files. The most complex file is this one, and it's why I wanted to, this one. Parses and execute SQL scripts. Because when I wrote that stuff, I have to do SQL parsing, and that's not a simple thing. We know that. And so the question, that's what now I'm talking a little bit about Java. Why Java has their operators or statements which allows to run system commands like ls or something. Why not to use that and just use just put it over there? You see, MySQL, and run that script. Why not to do that?
Why not?
Yeah, the problem is that it is not easy thing to do at all. It is really tough, and it is very well known weak spot of Java, that it does not run system commands very well. The reason is, you know, when you start up MySQL client, it's a separate process. So you start up one process from Java virtual machine, and you have to collect, you have to provide standard input, standard error, standard output. You have to do that by yourself and manage that pretty well. I couldn't do that, and I thought that because I'm stupid. Looking in the internet, I found that it is not the case. And people really found that it is easy to parse SQL than run that stuff through. Java improved a little bit from that time. Now they have some builder code in Java .5 and .6, but I didn't use it. We developed that tool, and it doesn't make sense to change it simply because they improved something in their code. But it is very reliable, it runs very well. Java has very nice error detection capabilities. It is really easy to work and find these things. And here, just a piece of code where I show, the kind of, you will see it is not easy, because now you have to, it is not only DDL, DML, but DDL is very different. What if you have a trigger? What if you have a stored procedure? MySQL has wonderful delimiter. You know what I'm talking about. And I have to handle that now. So this is a piece of code. If you look at, you will see that delimiter, how I handle that, and you have to handle starting delimiter and ending delimiter, you know, and put that old delimiter back, because now you have to parse based on the standard delimiter, on the semicolon. So, and a lot of stuff, you know, a lot of if statements and all of these things, until you got finally your connection. That's where, once you got into that, now things will be relatively smoother. But yeah, the code is not simple still. But yeah, it works, and we use it for. It's essentially cornerstone of our development, because this way we can make sure that our production and staging are the same state, have the same state, and developers also similar like that. Yeah, that essentially it. So once it is written and debugged, and debugging also a problem, because, for example, MySQL has two types of comments, like double minus. Also, it has a hash mark or pound. I don't know how to that type of things. So you have to debug different things. People do some strange thing, like they put comments inside SQL code. Logically, you're allowed to do that, and it could be very complex to handle. So we essentially ask developers not to do that. They could put their comments, but don't put them in the middle of SQL statement. Yes, that essentially it. Now, once we debug it and everything is done, it's really easy to use. It's very efficient, and developers put them into Eclipse and just run their scripts from Eclipse and put that stuff in. So yeah, that's essentially kind of a major drawback, and I still don't have time to do that, to lack of transactionality. So if something got wrong, just roll it back. But always there is a possibility to, once you have all sequence, you can restart it and run it from scratch. So it is not rolling back, but jump to the beginning and roll forward. That type of things. That essentially, yes, that essentially it, and yeah, probably that's it. So JDBC is a wonderful tool, and MySQL is very friendly with Java, and it is easy to work, and not too many dark corners over there, but there are. And recently I hit that dark corner. I'm writing now a program. If you have a large database, when database grows, your query is getting slower. Of course, it could be partition and all of that stuff, but we know, if, for example, we're talking about Amazon. When customer bought a book, it is likely, like in a few days, customer can return that book. But after a year, it's very unlikely. Refund after a year, probably it's even prohibited after 30 days. What it means is that after some time, the data in the database became completely static. They are no longer changing. what it means is that you no longer have updates. You just have selects. So your server could be optimized completely different. And it's, essentially it's different server. It's almost like a warehouse versus operational data store. Why not to take advantage of that and offload those almost static records to some other machine and let them be there? Well, you need to get the history, you go over there, but at least it does not slow down your ODS, which is very important. So that's what we're developing application to do that type of things. It sounds kind of easy, but in reality it is not, because this way you have to guarantee that there is no missing records in both things, and there is no additional ones. Yeah. What happened if something crashed? You know, you have to think about transactionality very carefully, all of that stuff. But important thing that tables, you want to select a record and just insert it, the same record. You even don't want to know what's inside the record. You just select it and throw that into this data warehouse. Unfortunately, according to the documentation, the JDBC doesn't allow you to do that because columns have different types. And you have to know in advance what type you are going to get in order to insert it. That's what I thought. And suddenly I found on internet kind of small example when one guy didn't do that. It used just strings. It cannot be. But I wrote my stuff. It works. Wow. I never thought about that. So, because we have support, I sent my question to my SQL people. And what that guy used, he used strings. Because you can represent every type with a string, you know. You can represent all numericals with a string, binary, even binary, you don't necessarily have to see those bits, but it will be string. And of course, text could be presented as a string, everything could be presented. So it's a lowest common denominator. What is interesting that if you insert the data into the table, which is particular column, for example, int, but you insert it as a string, what server is going to do, it look at the data which you're trying to insert and say, oh, this is string, but the data really integer. Why not to try convert it into integer? Maybe it will work. And it does. And if it is, it inserts and happy with that. I was amazed when I discovered that. And fortunately, MySQL confirmed that. They even talked with Matthews. What's his name? I forgot. You know the guy who wrote JDBC driver for MySQL.
Mark Matthews.
Mark Matthews, right. Mark Matthews. Yeah, he confirmed that. You cannot find that information in the documentation. Not documented. Amazingly. But it is important because you really don't need to create intermediate object in order to just store that data temporarily. And I also was surprised that even in JDBC there is no kind of temporarily storage. You just selected the record. And you don't want to know what's inside, and just inserted it back.
So Jacob, when you're talking about time-dated stale data, that's a fairly common warehousing thing to work with. Most people just have multiple tables that are dated by some time period and a view on top of it and roll off the first. And what's different about what you're saying than that? Why isn't it just that easy to manage it? Is yours a technique for looking anywhere in a database, or I'm not following what makes yours unique, what you're doing.
You're talking about catalog version tool or about another application?
The time tool that you're talking
Oh,
about.
there is nothing unique about that. The only unique is that it uses some dark corners of JDBC,
I see.
which never documented, but very beneficial.
I get it.
Very beneficial.
Thank you.
That's why I wanted to mention that.
I see.
Because it also, catalog version was written in Java, JDBC, and worked very well. I'm trying to emphasize the fact that Java is a very convenient language for working with the databases. Very convenient. It has all necessary supporting data types, all collections and all of that stuff. It's just ready. In addition to that, it has very good speed. Yeah.
So another question about the catalog version. I assume, so what most DBAs do is to deal with this in some way, not as well as you obviously, is create a blank database, perhaps with reference data in it, and then back that up.
Yep.
And then it occurred to me, maybe you could have a table within your database of the version that you've backed up, so when you restore it, you know exactly what you got. What would be missing from that your system would provide?
I see. You essentially storing the schema,
Right.
as a dump, for example, file.
As a template.
Yeah. But when you create dump out of that, that's still SQL file. You know that dump is SQL file, like using MySQL dump, for example. So I don't see, and if you look inside that, you see the SQL statements over there. I don't see big difference here.
Yeah.
What's different is granularity.
Is what?
Granularity.
Yes. Yes.
And granularity is important.
So you could look at parts of it.
Right, the size of the delta. And
so you can answer the question as to how much is different.
Right, and that's actually a very good point, because what I thought originally, I thought that once you accumulated like a couple of hundred of those SQL deltas, you could just merge them into one, big one.
Right.
It is nice to have a history.
Okay.
Once you merge them together, you forgot.
Thank you.
And if it will be difficult to apply them, I would agree with that. That's what you see. Where just answering your question.
No,
yeah, but because it's easy.
Right.
Yeah. Why to lose that? And history is very important. Yeah. That.
Are you familiar with dbdeploy or Liquidbase at all to handle these things?
Yes, there are multiple tools which do that. One of the things which they do, they compare, for example, your data, just like an editor. There are multiple tools.
No, I mean basically what dbdeploy and Liquidbase, they do revision changes and they track that in the database, very similar to what you're using or presenting right here. I'm trying to figure out if you have looked at those tools side by side to what
I think
you're doing.
dbdeploy is for SQL Server.
No, it's for MySQL. There's a branch for we use it right now in our production environment. It's not supported anymore. It's no longer supported, but we do use dbdeploy currently, and we're moving to Liquidbase, which does exactly the same, as well as provides rollback for transactional.
Right. Yeah, I know. Yeah, there are tools.
Right.
First, we didn't find the free one.
These are both open source.
Yeah.
Yep. So I'm trying to figure out what advantage.
Maybe not.
If you check these out in terms of what yours provides in side by side.
I don't know, because I didn't. I read about those tools, but we created these things by ourselves, and it fits into our framework.
Right.
We can manage those things, and there are some options which we really like. So it's kind of homegrown tool.
Yeah, and if you want to speak to me after, I can show you exactly what we're talking about.
But
It
it
may save you some time.
Yeah.
More what I'm trying to get to.
I know that there are similar tools, but some tools we didn't like. For example, they show you the difference between table in data, and that's useless because you have so much data you really cannot look at them.
Right, and these do database deltas in separate SQL files. They do branching code, so you can actually branch off and develop side by side with these database changes. I'm just trying to figure out where.
Yeah, well, that's. I kind of not pretending that this is completely absolutely new. What I'm pretending that it is convenient. It is with the Java you can run it on the same server where your database run. You can run it remotely. Nothing. It is very convenient for us. One of the problems with that tool, with those tools, was that in production, they don't allow to install any tool which you want.
Right. These are both standalone tools as well.
Right, but they have Java, and they tolerate some our own development,
Yeah.
but they very reluctant to. They even didn't allow us to install Perl in that.
Right.
They have to allow Java because the application is in Java. But so, and here we kind of know everything, so we kind of.
That's fair.
That essentially, yeah, that essentially it. Mhm.
So your presentation with catalog version, you focus mostly on going forward with the reference database. Are there any allowances for going backwards? Like if I want to go back to last week's reference database, does that mean I have to start from scratch and run all the scripts from the beginning?
Go forward.
Okay.
Yes, yes. So far, we did not have need, like too much need to go back. Usually we started and stopped before, yeah, one delta before.
Yeah.
To subtract data, no, we didn't do that. I thought about that a little bit, but just didn't have time.
Sure. Yeah. It's definitely a hard problem with this approach, but I know, like it was mentioned earlier, the idea of taking a dump of your database. You know, if you're doing weekly releases, you take a dump every week. That way, I can go back to last week's
I
reference
believe,
data set just by restoring that dump. So that would be, we were talking about what are the advantages of this approach. That would be one advantage of that approach.
I believe some of the tools do allow you to do that, like subtract something, but again, it's money and kind of complexity. Here we did it when we developed that. First, it was very basic, and after that, we understood the sophistication. Moreover, there are thoughts of how you can use that for QA, for example. Now you can read that particular table, and I show you. So you read it. QA, for example, can read, and if they have particular file, they could start up particular test. So here, the state of the database in your hand, that's the most important thing. And here they can use it, they know how to read it, it is not proprietary, at least for them. That is important.
Yeah.
We don't do that yet, but I hope we're going to use it for full regression testing automation. You know, what tests run depends on the version, depends on those particular scripts. Yeah. Also, I don't know, you're right about those tools, but another part of our team, which is in Europe, either they didn't read about them, but they spend a lot of time analyzing and comparing data. Once they got it, they were so happy. They didn't look into anything yet. I don't know, many, again, when I wrote that, I did study those tools, but not Liquid. I think I remember. I look at something, but we still decided to go with our stuff. Yeah. That, yeah. No, that's essentially it. Yeah.
Very good.
So I can add a few other words about using Java or with the data. Java, especially latest editions, 1.6 and 1.7, are incredibly fast. Incredibly fast. Because it's a dynamically linked language, it can optimize, it work on the fly. What it means is that doing complex transformations like XML, for example, you want to create Java object out of XML structure, whatever you call it, usually out of XML string. You have XML string, complex one, and you want to create object out of there because you really cannot store at the string in the database in a searchable way. You store a string as a blob, but you cannot search over there. So in order to create particular fields, you need to create object, flatten that object, and put it into table. And this is a very complex, resource-consuming process, because this is a string, complex structure, and create object. It's really very consuming. And if you do that multiple times, and when you store it, of course it's multiple times. You store XML in a loop. For example, you have a sensor which sends you data in XML format, and most of sensors do now, by simple reason of interoperability. So in order to store that data, you need to convert that XML into object, and object store object in a searchable way in the database. So Java knows that it runs essentially the same thing with a different data, and it optimizes that, and optimizes it tremendously. I couldn't believe my eyes when I did benchmark that it optimized it by 3 orders of magnitude. So after about like tenth of 1,000 iterations, and it's 10,000 iterations, it's very small what you're talking about, sensors, it's nothing. It increased its speed by 1,000 times. 1,000 times. Could you imagine that on the same hardware you got such increase? I couldn't believe it. So I'm a big kind of proponent of Java and advise you to use it. It's a great language. Comparing with the C++, it's about 3 times faster to program. Yeah, we did just comparison programming, about 3 times faster. Yes, you have built-in graphical input, graphical output, you have built-in database, you have built-in everything, and inside one language. That's it. Okay, thank you.
Okay. There are mugs if you guys want to take from OpenSQL.